What if I told you that the greatest lie ever sold to humanity, more seductive than any religion, more dangerous than any weapon, is the idea that we can send people to Mars and simply bring them back? What if the engineers know this? What if the scientists know this? What if the billionaires launching rockets into the sky know this, and nobody is saying it out loud? What if the real plan was never a round trip? Right now, somewhere in a boardroom, someone is calculating survival odds and calling them acceptable. Acceptable. That word. That one word buried in a 400-page mission document that nobody reads. And inside that word lives the dirty, brutal, uncomfortable truth that I'm about to hand you. Raw, unfiltered, and backed by physics that does not care about your dreams, your funding, or your applause. So buckle up, because in the next few minutes, reality is going to hit you harder than a Mars surface landing with a failed parachute. And once you hear this, you cannot unhear it. What if the very rocket fuel needed to leave Mars doesn't exist on Mars, and nobody has actually solved how to make it there? Here is something that will make your stomach drop. To lift a rocket off the surface of Mars and escape its gravitational pull, you need an enormous quantity of propellant, liquid oxygen, methane, or hydrogen. These do not exist in ready form on Mars. The atmosphere is 95% carbon dioxide, thin as a whisper, and the soil is a frozen, toxic desert. Scientists talk about in situ resource utilization, a beautiful, technical, almost poetic phrase that essentially means figure it out when you get there. But here is the terrifying part nobody puts in the press release. This technology has never been tested at scale, in actual Martian conditions, under the radiation bombardment of deep space, with equipment that has traveled 300 million miles and may have cracked, corroded, or simply stopped working. We are betting human lives on a chemistry experiment that has never been run outside a laboratory on Earth. The margin for error on Mars is zero. Physics doesn't offer extensions. Nature doesn't accept apologies. And a human being stranded on Mars, waiting for fuel that cannot be produced, is not an astronaut anymore. They are a monument. What if the human body begins destroying itself the moment it leaves Earth's magnetic field, and 6 months of space travel to Mars is already a point of no return? This one is not a theory. This is biology turning against you in real time. The moment you leave Earth's protective magnetosphere, your body enters a war zone of galactic cosmic rays, high-energy particles that pass through metal, through suits, through flesh, through DNA. They don't burn you, they don't cut you, they quietly, invisibly, systematically dismantle your cells. Studies on astronauts returning from the International Space Station, and they were only 400 kilometers above Earth, show significant cognitive decline, vision damage from intracranial pressure changes, bone density loss of up to 2% per month, and immune system collapse. Now multiply that by a 7-month journey to Mars in deep space with no magnetic shield. By the time an astronaut lands on Mars, they are already physiologically compromised. Their vision may be permanently damaged, their bones are brittle, their immune system is struggling. And now you want them to build a rocket, mine fuel, and launch back into space? The math is not cruel. The math is just honest. What if a 26-month communication delay between Earth and Mars means that if something goes catastrophically wrong, no human voice from home can reach you in time to matter? Imagine this. Your life support system begins failing. You have a problem. You call home. And you wait. You wait 24 minutes for your signal to reach Earth. Then you wait another 24 minutes for the answer to return. By the time Mission Control says, "Here is what you should do," 48 minutes have passed. In a spacecraft emergency, 48 minutes is not a delay. It is a death sentence. Every single decision, every repair, every medical emergency, every structural failure must be solved by the crew alone, in real time, with whatever knowledge and tools they brought with them. No rescue mission can reach Mars in under 7 months. No supply drop is possible. No emergency surgery team can be flown in. The crew is an island, not metaphorically but physically, cosmically, absolutely. And the return journey? It requires a launch window that only opens every 26 months due to planetary alignment. Miss the window due to illness, equipment failure, or anything, and you wait another 26 months on a planet trying to kill you. What if the psychological destruction of isolation, confinement, and existential dread is more likely to end the Mars mission than any mechanical failure? We tend to think of space as a technical problem. We pour billions into rockets and radiation shielding and life support, but we almost never talk about what happens inside the mind of a person who is farther from home than any human being has ever been, who cannot see Earth with the naked eye, who knows that if they die, their body will stay on Mars forever. Psychological studies on isolated Antarctic crews, submarine crews, and simulated Mars missions show a consistent, predictable pattern. After a few months, communication breaks down, trust collapses, cognitive function degrades, and decisions become irrational. Now place that same human in a vehicle the size of a small apartment for 7 months, with the same 4 people, with no escape, no nature, no privacy, no fresh food, no random human interaction. And then land them on a dead planet where the sky is the wrong color and the silence is absolute. Psychiatrists call it third quarter phenomenon, the psychological collapse that happens when a mission's end feels unreachable. On Mars, the end is always unreachable. The return is always a question mark. What if the landing itself, the most technically complex maneuver in human spaceflight history, has a failure probability that no space agency will publicly state out loud? Mars has an atmosphere. Not much of one, about 1% of Earth's, but just enough to make everything complicated. Too thick for a pure rocket landing. Too thin for parachutes alone. Every Mars landing, therefore, requires a terrifying combination of heat shields, supersonic parachutes, retro-rockets, and sometimes airbags or sky cranes, all deployed in a sequence that must work perfectly in under 7 minutes. Engineers call this the 7 minutes of terror. And that is for unmanned rovers weighing a few hundred kilograms. A crewed lander would weigh tens of thousands of kilograms. We have never successfully landed anything that heavy on Mars. Not once, not even close. The largest thing ever soft-landed on Mars was the Perseverance rover at about 1,000 kilograms. A crewed vehicle would be 20 to 40 times heavier. The physics of scaling up this problem are not linear. They are exponential. And we are asking human beings to sit inside this unproven, unskilled, untested system and trust that it works, the first time, with no second attempt. What if the return journey, launching from Mars, navigating 300 million miles, re-entering Earth's atmosphere, is so statistically stacked against survival that the mission architects have already quietly accepted a one-way outcome? Let's do something radical. Let's follow the chain of events required to bring a human being home from Mars. First, you must manufacture fuel on Mars. Never done. Then you must successfully launch from Mars. Never done. Then you must navigate a 7-month journey back with a crew that is physically and mentally degraded. Never done. Then you must perform a precise re-entry into Earth's atmosphere at 47,000 kilometers per hour. Done, but only from low Earth orbit, never from interplanetary speed. Any single failure in this chain is not a setback. It is the end. There is no rescue, no repair, no second chance. And here is the part that nobody says at the press conferences, the part buried in the asterisks of mission documents. The probability of all these systems working perfectly, sequentially, after years of exposure to deep space radiation and Martian conditions, is not high. The engineers know this. The physicists know this. And somewhere, in the quiet honesty of a late-night calculation, the people building these missions know this too. What if I told you that everything you have been told about going to Mars is true, and everything you have been told about coming back is a beautiful, expensive, well-funded fairy tale? We love the idea of Mars. We have loved it for a century. In our science fiction, our movies, our childhood dreams of red horizons and alien sunsets. And now, for the first time in human history, we are close. Rockets are being built. Timelines are being announced. Billionaires are making promises on stages with countdown clocks behind them, and audiences are cheering. I am not here to take away the dream. I am here to hand you the physics. Because physics does not cheer. Physics does not attend press conferences. Physics does not care about your funding round or your scheduled launch date. Physics simply sits there, patient, absolute, indifferent, and waits for you to meet it on its own terms. And the terms, when you read them carefully, are brutal. The first thing you must understand is fuel. To leave Mars, you need propellant. Propellant that does not exist on Mars in any usable form. The plan, and it is a real plan, published in real documents by real agencies, is to manufacture it there. To take the thin Martian atmosphere, process it chemically, and produce the liquid oxygen and methane needed to launch a rocket. This has never been done on Mars. It has never been done at the scale required. It has never been tested under real Martian radiation, real Martian temperature swings, real mechanical degradation after years in deep space. We are wagering human lives on a chemistry experiment with no rehearsal. And if the experiment fails, if the equipment breaks, if the yield is insufficient, if the timeline slips, the crew does not get a refund. They get a grave on a planet 300 million kilometers from home. Then there is the body. The human body. This magnificent, resilient, absurdly fragile machine was built for one planet. Its blood pressure, its bone density, its vision, its immune function, its DNA repair mechanisms, all of it calibrated over millions of years for Earth's gravity, Earth's magnetic field, Earth's radiation environment. The moment you leave Earth's magnetosphere, cosmic radiation begins its quiet, invisible work. It passes through your spacecraft walls, through your suit, through your cells. It doesn't announce itself, it doesn't burn. It simply reaches into your DNA and introduces errors that accumulate silently over months. By the time an astronaut arrives at Mars after a 7-month journey, they are already compromised, vision damaged, bones weakened, cognitive function measurably degraded. And this is before they set foot on a planet where the radiation dose continues, where the soil is toxic perchlorate, where a dust storm can last months and block the solar panels they depend on for survival. And then there is the silence. People do not talk enough about the silence. The 24-minute one-way communication delay between Earth and Mars means that real-time conversation is impossible. If your life support fails, you call home and wait 48 minutes for an answer. If a crew member has a medical emergency, you are the doctor. If your lander develops a structural fault, you are the engineer. There is no calling for help. There is no cavalry. Mission control becomes at best a slow-moving advisory board for decisions you must make alone in the moment with the information you have. And if you miss your 26-month launch window back to Earth, due to illness, equipment failure, weather, anything, you wait. On Mars, for another 26 months. On a planet with an average surface temperature of negative 60 degrees Celsius, no breathable air, no liquid water, no food that isn't in a pouch. Now I want to talk about something that almost never makes the headlines. The mind. We are very good at engineering machines. we are not very good at engineering the human psyche. Study after study of isolated confined crews, Antarctic researchers, submarine sailors, simulated Mars mission participants shows a pattern so consistent it has a name: psychological deterioration. After months of confinement with the same small group, in the absence of natural light and sound and human variety, the mind begins to fracture along its fault lines. Communication breaks down. Irritability becomes aggression. Decision-making becomes impaired. And this is on Earth, with resupply missions possible, with the horizon of home visible. On a Mars mission, there is no horizon. There is no home visible in the sky. There is only the red desert, the thin, howling wind, and the knowledge that you are farther from every other human being who has ever lived than it is possible to comprehend. And if somehow the fuel is made, and the body holds, and the mind survives, you must still land. You must navigate 300 million miles of deep space, re-enter Earth's atmosphere at 47,000 kilometers per hour, and trust that a spacecraft that has spent months in the cold void, bombarded by radiation, operated by a crew operating at degraded capacity, will execute a flawless re-entry from interplanetary velocity, something that has never been done. Here is the question I am leaving with you, and I want you to sit with it honestly. When the people building these missions talk about acceptable risk, who exactly is doing the accepting? Not the engineers behind their desks, not the executives behind their podiums, not the audiences behind their screens. The person accepting the risk is the one sitting in the seat, the one who trained for years and believes in the mission and is willing to go, knowing, truly knowing, in the part of themselves that reads the footnotes, that the probability of return is not what the press release suggests. I'm not saying do not go to Mars. The science is extraordinary. The knowledge we would gain is extraordinary. The human courage required is extraordinary. But let's be honest about what we are asking. We are not asking for explorers who will plant a flag and come home for a parade. We are asking for people willing to go to Mars and accept, in the quiet, private, 3 a.m. honesty of their own hearts, that coming back is not a plan, it is a hope. And hope, however beautiful, is not an engineering specification. The universe does not grade on optimism, it grades on physics. And physics, right now, is not giving this a passing mark. What began as a dream, boots on red soil, humanity touching another world, reveals itself under honest scrutiny to be only half a dream. The going is possible, the returning is where physics draws its line in the dust. 6 forces conspire against the return. Fuel that must be conjured from a hostile planet, a body that space systematically dismantles, a communication delay that makes real-time help impossible, a psychology that confinement will eventually break, a landing challenge we have never solved at human scale, and a return chain so long and so unforgiving that a single failure anywhere ends everything. This is not pessimism. This is the most important form of respect. Respect for the truth, respect for the people who will sit in those seats, and respect for the mission itself. Because a mission built on incomplete honesty is not a mission. It is a spectacle. The greatest tribute we can pay to human courage is not to cheer it blindly. It is to equip it fully, with real numbers, real probabilities, real contingency plans, and then, only then, ask someone to go. Mars is waiting. It has been waiting for 4.5 billion years. It can wait a little longer while we get the math right.